convert standard notation to scientific notation. So the scientific notation format is a number times 10 raised to an exponent. So we'll leave as a variable a. And then when establishing the first number, we will move the decimal so that only one number is to the left of the decimal. So like this. That's how we would want to have it in, where only one number is to the left of the decimal. And so when determining the exponent, we will count the number of times that the decimal is moved. And so in deciding the integer, which is our exponent, if the decimal moved to the left, it is positive. And if the decimal is moved to the right, it is negative. So this is the opposite than when converting to the standard notation. And this will make sense when we do a few examples. So example 1. The clearance between valve stem and a valve guide is important for proper valve lubrication and reasonable oil consumption. Thus, 2 measurements are done. The first measurement shows the diameter of the valve stem is 0.3414 centimeters. The second measurement of the valve guide is 0.3459 centimeters. So the difference between the two is 0.0045. What is 0.0045 in scientific notation? So what we have is we will rewrite this. And so we need to get this in a number times 10 raised to an exponent. So we are going to have to move this decimal to the right. And so when we move to the right, we could move it 1, 2, 3, and we will end right there. So our new number, which is right here, becomes 4.5. And then we need to go times 10 to the... Now we notice that we moved to the right. And so when we move to the right, when converting to scientific notation, that means our exponent will be negative. And we moved it over 3 times, so it's negative 3. So this would be our number in scientific notation. So let's do another example. Example 2. So the tachometer, or the RPM gauge, shows the car engine is currently turning at 2,400 RPMs. What is 2,400 or 2,400 in scientific notation? So we will rewrite this number like this, and we have a decimal right here. So we notice that we need to move the decimal to the left, and so we'll do it 1, 2, 3. So we're going to end right there. So our new number becomes 2.4. So we have number times 10 raised to an exponent. So this is our number, and we're going to multiply it by 10. Now, when we move it over to the left, we actually have a positive exponent. So, and then how many times do we move it over? So we moved it over 1, 2, 3. So it's just positive 3. So we have 2.4 times 10 raised to the 3rd power. And this would be our number in scientific notation. So let's go ahead and look at another example. Example 3. The tachometer, or RPM gauge, shows that the engine is currently turning at 4,300 RPMs. What is 4,300 in scientific notation? So once again, we have our number, we have our decimal here, and we're going to need to move to the left. And we need to move it to the left until we only have one number, which is the 4, to the left of the decimal. So our new number then, and we'll leave out those zeros, and we're left with 4.3. Because we don't need to keep those zeros, as we will account for it in our exponent. So we have our number times 10, and then we moved over 1, 2, 3. So we moved over 3 times, and we moved to the left, so it's positive. And this would be our number in scientific notation. So let's do one last example. Example 4. The clearance between a valve stem and a valve guide is 0.37814. What is 0.37814 centimeters in scientific notation? So for this problem, we have 0.37814. Now, we notice we have a decimal here, and we need to move it over 1. Because then we have one number, an actual number that's not 0, to the left of the decimal. So our new number then becomes 3.7814. Now we kept more numbers because these aren't zeros, so we can't disregard them. So we actually have to write all of this out. So we have 3.7814 and then times 10, and we moved over to the right. So that means we're going to have a negative exponent, and we just moved over once. So this would be our number in scientific notation.